Alright, so let's solve another example on cylindrical coordinates. Here we want to set up the integral to find the volume of the shape bounded by the two surfaces. We have z is equal to the square root of x squared plus y squared, and the other surface is x squared plus y squared plus z squared equal 1. And we don't have to evaluate the integral, we just need to set it up. So I suggest you pause the video and try and solve this problem yourself, then come back and see how I solve it. Okay. So, if we try and have a sketch of the solid, first we have z is equal to the square root of x squared plus y squared, which means that z is equal to the square root of r squared, so z is equal to r. And if you sketch this on the zr plane, say this is r, this is z, you're gonna have a straight line of slope equals to 1. So the radius or r goes radially outwards in all directions, and as we move radially outwards the value of r increases, hence the value of z increases. So this becomes an equation of a cone. And we take a look at the other equation. We have x squared plus y squared plus z squared equal 1. And we know that this is an equation of a sphere that has a radius 1. It's 1, 1, 1. And the volume bounded between the two surfaces is going to be this solid over here, which looks like an ice cream cone. So if I sketch it outside on its own, it's going to look something like this. So that's the solid we're trying to find the volume of. Okay, so since the projection of the shape on the xy plane is going to be a circle, it's probably going to be a good idea to find the volume of the shape using cylindrical coordinates. So we know that the volume is equal to the triple integral over the region r, 1 dv. In cylindrical coordinates, that becomes 1 times r dz dr d theta. Okay. So let's set up the limits of integration in the z direction. In order to do this, I'm going to sketch arrows in the positive z direction. And I see that I always enter the region through these lines over here, or through the cone given by z equals to r. So I always enter the region at z equals to r, and I always exit the region through this part over here, and this is part of the sphere that has the equation x squared plus y squared plus z squared is equal to 1. Now I want to have z is equal to something here, so I'm going to rewrite this. I know that z squared is equal to 1 minus y squared minus x squared, which means that z is equal to the square root of 1 minus y squared minus x squared. Okay, now we need to set the limits in the r and theta direction. So you look at the projection of the shape on the xy plane, and you find the projection of the shape on the xy plane is going to be a circle. So the lower limit of r is going to be 0, and the upper limit is going to be the value of this radius over here, the radius of the circle. So one way we can find the radius of this circle is by looking at this upper circle here, because this circle is the projection of this circle. And we can find the radius of this circle by doing the simultaneous equations. Z is equal to r and z is equal to the square root of 1 minus y squared minus x squared, because this circle is the intersection of these two surfaces. So if we want to find the value of the radius of this circle, we're going to have to do the two equations simultaneously. So we have the surface z equal to r, and z is equal to the square root of 1 minus y squared minus x squared. So I can rewrite this, z is equal to the square root of 1 minus r squared. So r is equal to the square root of 1 minus r squared. I'm going to square both sides, so I get r squared is equal to 1 minus r squared. So 2r squared is equal to 1. I'm going to divide by 2 on both sides. I'm going to get that r squared is equal to 1 over 2. Therefore, the value of the radius is 1 over square root of 2. So the radius of this circle and the radius of its projection here is going to be 1 over root 2. So the upper limit of the radius is going to be 1, let me use a different color, it's going to be 1 over root 2. And since this circle here is a complete circle centered at the origin, it's defined in the 4 quadrants on the xy plane. Theta is going to go from 0 to 2 pi. So let me rewrite this. The integral to find the volume is going to be r dz dr d theta. Z is going to range from r to the square root of 1 minus y squared minus x squared. So negative y squared minus x squared is going to be r squared. R ranges between 0 and 1 over 2, sorry, 1 over square root of 2, and theta is going to range from 0 to 2 pi. And if you evaluate this integral, you're going to get the volume of the solid. Yeah, so that's the final answer. Let me box it. If you have any questions, leave them down in the comment section below, and I'll be more than happy to answer them.